Ako po ba magdi-discuss ng solution, ma'am?
Mm.
Sa ano po? Sa pagkuha po ng temperature to, ang ginamit po dun na formula ay ano, yung Q equals mCp delta T.
Mm.
Tapos po, dahil meron pong CP, ay, meron pong R at K na given, ginamitan ko po nung CP is equal to RK over K minus 1.
Okay.
Then since yung R po is na ano, ang unit po nung R is joule per kilogram Kelvin. Kinonvert ko lang po into kilojoule per kilogram Kelvin po.
Okay.
So naging ano po, 0.319 kilojoule per kilogram Kelvin times 1.26 over 1.26 minus 1 po.
Okay.
Then yung lalabas po na CP doon is 1.5459230077. Then ano po, lahat po di magagamit na po yung formula na Q is equal to mCp delta T. So magiging 120 kilojoules equals 3 kilograms times yung lumabas pong sagot sa CP times T2 minus 305.15 Kelvin po. Then sinipsolve ko na lang po, tapos ang lumabas po ay 331.0245086 Kelvin po.
Mm.
Sa ano naman po, sa internal energy naman po, ang formula po nun is delta U is equal to mCV delta T. Yung
Mm.
CV po, wala pang value. Pero meron naman nga pong R at K. So, kinuha po muna ang value ng CV, which is CV is equal to R over K minus 1. E di 0.319 over 1.26 minus 1 po. Then, ang nakuha ang CV naman po ay 1.226923077.
Mm.
Then, in-input ko lang po yung mga values na yun dun sa formula. So, ang lumabas na nga po is 95.2380951 kilojoules po.
Your answer is 95 point
2380951 kilojoules po.
9 kilojoules. Okay, letter C.
Tapos naman po sa work non-flow, yung work non-flow po kasi merong tatlong possible na solution, ay tatlong possible na formulas po. Pero ang
Mm.
ginamit ko po dun is yung work non-flow equals mR delta T. Since
Okay.
yun po, edi in-input ko lang po na 3 kilograms times 0.319 times 331.025 minus 305.15 po. Tapos ang lalabas po dun ay 24.76190473 kilojoules po.
24 point.
76190473.
Okay.
Last naman po is yung sa entropy. Ang sa entropy naman po, may dalawang possible na formulas din po. Ang
Mm.
ginamit ko po dun ay yung MCP ln T2 over T1. So, since lahat naman po nung kailangan sa formula meron, in-ano ko lang po. In-input ko lang po doon. Tapos ang
Mm.
lumabas po na sagot ay 0.3777463 kilojoules po.
Okay. Clear. So I think na-discuss Mr. Hassan discussed the solution well. Were you able to get the same answer, class? How about the others? Adham, how about you? Were you able to get the same answer? Okay. Any questions, class, for on sample problem number 36? Ano yan, Sayus?
Ma'am, may nag-chat po ako sa message.
Ah, yes. I just replied.
Thank you po.
Okay. Okay, let's proceed to the next problem, which is your assignment as well. Anyone who wants to answer? Wants to share his or her answer? Yes, Miss Seda, please discuss your answer. Tell me first your answers and then send it to your GC once verified. What are your answers?
Sa A po ay 894.45 Kelvin po.
Okay.
Sa B naman po ay 154.0327869 kilojoules po.
Okay. Correct.
Sa C naman po ay 118.0327869.
Again, sorry. What's your answer? Delta U is?
118.0327869 po.
Okay. And then last?
36 kilojoules po.
Okay. Correct. So, kindly share your solution to your classmates and let's discuss. Please also read first the problem.
Okay na po, ma'am.
Yep.
Sample problem number 37. A certain gas with Cp equals 2.215 kilojoules per kilogram Kelvin and K equals 1.305 expands from 0.15 cubic meter and temperature T1 equals 25 degrees Celsius to 0.45 cubic meter, while pressure remains constant at 120 kilopascal. Compute T2, Q, delta U, and work non-flow. Sa pagkuha po ng final temperature, ang ginawa ko po is T2 over T1 equals V2 over V1. Tapos
Okay.
po naging T2 equals T1 V1 over T1 V2 over V1. Since given
Correct.
naman po lahat, in-input ko lang po, naging sagot po ay 894.45. Tapos sa pagkuha po ng heat, ang ginawa ko po ay kinuha ko po muna ang mass gamit ang PB equals MRT pero hindi po given ang R. Pero may given naman po na CP tsaka K kaya ginamit ko po yung CP equals RK over K minus 1. Tapos in-input ko po tapos shift solve, ang lumabas po ay R equals 0.5176819923 kilojoules per kilogram Kelvin. Kaya po
Mm-hmm.
makukuha na po yung mass gamit po yung PB equals MRT. I-input lang po lahat ng 120 times 0.15 equals mass times 0.5176819923 times temperature po na 298.15, ang magiging mass po ay 0.1166 240 ay 0.1166 kilogram. Tapos po sa pagkuha naman po ng heat, MCP delta T, since given na po yung CP, i-input lang po. Magiging final answer po ay 154.0327869 kilojoules.
03 27.
27869.
Okay.
Sa pagkuha naman po ng delta U equals MCV delta T. Wala pong given na CV, kaya po kukunin muna po kung yung CV. Ang ginamit ko pong formula ay yung CV equals CP minus R, pero pwede naman din po yung CB equals R over K minus 1. Ang magiging final answer po doon ay 1.697318008. Tapos po, input lang po para makuha yung delta U. Magiging answer po ay 118.0327869 po.
118.0327.
327869 po.
869 kilojoules. And then last,
Work non-flow naman po, work non-flow equals MR delta T po. Since given na din po lahat kasi nakuha na po sa unang mga letter po, ang magiging final answer po ay 36 kilojoules po.
36 kilojoules. So everything is correct. How about the others, class? Did you get the same answer? Do you have any questions on the solution? How about the others? Raise your hand if you get the same answer. Mm-hmm. Aldrin, Adham, Alan May. How about you? Ninya? Okay, so if the solution is clear, let's now proceed. Okay, lower your hands na. Let's proceed to the next topic, which is the isothermic process or isothermal process. Let me just clear this slide. So, punta na tayo on the third ideal gas process. So this is isothermal process. Okay, based on the discussion yesterday, what is constant in an isothermal process? You can just open your mic and tell the answer. No need to raise your hand. Correct. So, the temperature is constant. So, an isothermal process, class, is a reversible, constant temperature process of an ideal gas or a thermodynamic substance. So, the PV diagram of an isothermal process is like this. So, you have your pressure here, you have your volume here on the x-axis, and then if you have your state point 1 on this point, in an isothermal process, this is how your PV plane will look like. This is your work non-flow. The area under the PV plane is your work non-flow. Okay, next naman is our TS diagram for an isothermal process. So the TS diagram, class, will look like this. Since your temperature is constant from state point 1 to state point 2, so like this, your Q or your heat transfer is the area under this line. So basically, it's just the temperature multiplied by your change in entropy. Okay? So let us derive the formula under isothermal process using the 7 general equations. So first one is the combined gas law. So we have P1 V1 over T1 is equal to P2 V2 over T2. So since our initial and final temperature are the same, pwede na po siyang makancel. It can be cancelled already. So what you'll be left with are P1 V1 and P2 V2. So this is already your equation for any ideal gas, for the combined gas law. So you can also rewrite this as P1 over P2 is equal to V2 over V1. So you can also write it this way. Okay? Next naman, let's proceed to the work of a non-flow system. So for the work non-flow or non-flow work, we'll have P1 V1 ln of V2 over V1. So this also came from the integration times ln of V2 over V1. Next, for the change in internal energy. So what do you think is the change in internal energy for an isothermal process? Diba? The formula here is mcv T2 minus T1. However, your T1 is equal to T2. Therefore, itong term na to will become 0. So, your delta U in an isothermal process is 0. Questions, class? All clear so far? Okay. Next naman, we have your change in enthalpy. So, same formula from the general equation. We have our change in enthalpy equals mCp delta T. However, again, our T1 and T2 are equal. So you can already, this is already 0. Therefore, our delta H in an isothermal process is equal to 0. So our delta U and delta H are both 0. Okay, next we have our heat transfer. For the heat transfer class, so this is our Q. Q is equal to P1 V1 ln ng V2 over V1. If you notice, this is just the same as your work non-flow. Why? Diba, on the first law of thermodynamics, we have our delta U is equal to Q minus W. However, in an isothermal process, your delta U is equal to 0. So, this will be 0 is equal to Q minus W or work non-flow. And if you transpose, our Q will be equal to the work non-flow. That's why this is the same as the work non-flow. And based on the first equation from the combined gas law, we can also rewrite this as P1 V1 ln of P1 over P2. Or pwede rin class that our heat will be MRT T1 or T2 since our temperature is constant, ln of V2 over V1. Or we can also write this using the pressure. So we can have it as MRT1 or T2 ln P1 over P2. So you can use any of these four formula. Clear class? So same with your work done flow. No, you can get your work done flow using any of these formula. Okay, next we have your um work of steady flow system. So work steady flow is equal to Q minus RPE plus, sorry, this is change in potential energy plus change in kinetic energy. However, in most of the cases, these two change in energies are negligible. Therefore, our work steady flow is equal to Q, which our Q is equal to the work done flow. And lastly, for the change in entropy, so this will follow the formula MR ln of V2 over V1. Or we can also use this. Our delta S is equal to Q over T. If given yung heat and given yung temperature. Okay? Let's have a sample problem. So this is sample problem number, ano tayo? 39, 38,
38 po.
38. Okay. Sample problem number 38. During a reversible process, there are abstracted of 317 kilojoules of heat from 1.34 kilograms of a certain ideal gas while the temperature is constant. At 27 degrees Celsius. For Cp is equal to 0.232 kilojoules per kilogram Kelvin. Cv is 1.713 kilojoules per kilogram Kelvin. And initial pressure of 586 kPa. Find letter A, P2, letter B, V1 and V2, and letter C, find the change in entropy. Okay, so for this problem, let us analyze the given data first. So this, in the problem, it was mentioned that the temperature is constant. So this is an isothermal process. And then we have heat that was abstracted from the process. So our heat or Q is equal to 317 kilojoules. Next, we're given of the Cp, which is 2.232 kilojoules per kilogram Kelvin. We have our Cv given also, which is 1.713 kilojoules per kilogram Kelvin. We're also given of the temperature. Can someone convert this to Kelvin? What's the answer here?
300.15 Kelvin.
300.15 Kelvin. And lastly, we're also given as the initial pressure, which is 586 kPa. Okay, so first we are asked to find the the final pressure. How do you think? How can we get the final pressure? What do you think? What will be the solution for this requirement from the formula that were presented here? How can we get the final pressure? Which amongst these formula will be used?
Formula po ng heat.
Correct. So we are going to use the formula of heat. So based on these available formulas, which one amongst these four will be used?
Yung MRT, ln P1 over P2 po.
Correct. Very good. So we are going to use this formula, MRT1 ln of P1 over P2. Sorry, I forgot to also write here the mass, which is 1.34 kilograms. Okay, using the formula of heat, which is Q is equal to MR T1 times ln of P1 over P2, we will just substitute the given data, leaving P2 as unknown. So we have one equation, one unknown. So you can use shift solve to get for the value of P2. So Q is abstracted, meaning heat loss. So this is negative 317 kilojoules. This is equal to 1.34 kilograms times our R is it given? R is not given. So we have to solve for first for the value of R. So R can be solved by just subtracting CV from CP. So what is our R? This is 2.232 kilojoules per kilogram Kelvin minus 1.713 kilojoules per kilogram Kelvin. What's the answer here, class?
0.519 po.
Yes, 0.519 kilojoules per kilogram Kelvin. So we already have the value of R. So we can substitute that here. So 0.519 kilojoules per kilogram Kelvin. Next, ln of P1 natin is given. So we have here 586 kPa over P2, which is the unknown. So using shift solve, what is the answer for P2, class? Two six seven five point 626. Wala na siya kasunod? Wala na. I mean, wala nang kasunod yung decimal point. Okay, okay. Sige, thank you. So your P2 is 2675.626 kilopascal. Okay, next. So okay na tayo on the P2. Next, we are asked to find the value of V1 and V2. For V1 class, can we get this already? What do you think is the solution to get V1? Which formula will be used? We have T1, we have P1, we have M1, we have R.
PVMRT po.
Correct. We will just use the formula PVMRT or the ideal gas law. So since our initial pressure is given, the temperature is given, so this T1 here is also equal to T2 since this is an isothermal process. Also given of the value of mass. And R we can compute. So we can use the formula PVMRT. So letter B for B1, dito na lang. Solving for V1 and V2. Again, V1 natin will be solved using PVMRT. So V1 will be equal to MRT over P1. So since everything here is given, we can directly substitute the given data. So V1 is equal to 1.34 kilograms times our R, which is 0.519 kilojoules per kilogram Kelvin. So, okay, MRT, T1 natin is 300.15 Kelvin. And then our initial pressure is 586 kilonewton per meter squared or kilopascal. So we can cancel this Kelvin here, the kilogram here. So this is kilonewton meter, right? So kilonewton can be cancelled here. This is kilonewton meter. So kilonewton can be cancelled. So when we reciprocate this unit here, it will become m times m squared. So our final unit here is cubic meters. So using your calculator class, what's the value of V1?
0.35621
55614 cubic meters. Or in three decimal places, this will be 356 cubic meters. So okay na tayo kay V1. How will we solve then for the V2, for the final volume? What do you think? How can we solve for the final volume?
Pwede na po yung equation.
Which equation?
Yung B1 over B2 is equals to B2 over B1 po.
Okay, yes, correct. So we can already use this formula, class. So P1 over P2 is equal to V2 over V1. So let's write P1 over P2 is equal to V2 over V1. V2 will be equal to P1 V1 over P2. So let's just substitute. We already have this data here. Our P1 is 586 kPa. Next, our initial volume. So we got that here, which is 0.35621555614 cubic meters over the final pressure, which we got earlier. So that's 2675.626. But the one you will be using here, class, is the non-rounded pa, ha. Do not use the rounded data. So you'll use the original value here. So V2 then will be okay, 0.0780 over your V2 is equal to 0.078 cubic meters. And this is your final volume. Okay, next requirement. So we already have the final pressure, the initial volume, and the final volume. Next and last requirement is the change in entropy. For the change in entropy class, we will be using the this formula. By the way, we can also use here MR times ln of P1 over P2. Since V2 over V1 is equivalent to P1 over P2. Okay, so let's solve for the change in entropy. So letter C, change in entropy is the requirement. We are going to use the formula MR ln of V2 over V1. So this will be, we'll just substitute our data that we got from the previous requirements. So this will be 1.34 kilograms times 0.519 kilojoules per kilogram Kelvin times ln of V2 natin is 0.07801626299 cubic meters, and our initial volume is 0.35621555614 cubic meters. So what is the change in entropy? Hello? What's the change in entropy, class?
Negative 1.056138.597 po.
Negative 1.05
6138597.
13
8597.
597. What's the unit here? Unit is kilojoules per Kelvin. So your delta S final answer is negative 1.056 kilojoules per Kelvin. And that's your final answer. Okay, so for your assignment, sample problem number 39. SP number 39. Have 2 kilograms of air. Gain 0.95 kilojoules per Kelvin of entropy. If P1 is equal to 830 kPa and V2 is equal to 1.20 cubic meters. Determine AV1 and T1, and letter B, work non-flow. Okay, so this will be your assignment, and this will be written also in your notebook. Okay? Okay na? Just take a screenshot and then we'll proceed with our next topic. So next topic natin will be the next process, which is constant entropy. So let me just clear this slide as well as this slide. Fourth process natin is isentropic. In an isentropic process, the constant parameter here is the entropy. Okay? And the process here, diba, from the discussion we had yesterday, your K is equal to N. So from the ideal gas process formula, we'll have here our PV raised to K is the one that is constant. So galing din yan do sa PV raised to N. Since in an isentropic process, your N is equal to K. Same with the adiabatic process. So an isentropic process class is a reversible adiabatic process. Adiabatic means no heat is transferred. So in an adiabatic process, no heat is transferred. And since the isentropic process is a reversible adiabatic process, meaning yung reversible adiabatic natin is a constant entropy process. So let's have the PV and TS diagram for this process. For the PV plane, we have here your pressure and volume. And then if we have here your state point 1, this is your state point 2. And the area under the plane, this PV plane, is your work non-flow. So this is just the same as the previous process, the isothermal process. Next, we'll have sorry. We'll have our TS diagram, and since our entropy is constant from state point 1, we have here and going to state point 2, our entropy is the same. So example, you have here your value. So from state point 1 to state point 2, your entropy value is the same. It is only the temperature that is changing. Okay, so let us now have the relationship of the parameters in an isentropic process using the combined gas law or the ideal gas process equation. So since our P1 V1. So first one is the relationship P1 V1 raised to K. This is the constant. So this will be equal to P2 V2 raised to K. And then we have to remember other relationships. So we will relate temperature to volume, and later on we will correlate temperature to pressure. So first one, temperature and volume, we will have the relationship where our T2 over T1 is equal to V1 over V2 raised to K minus 1. T2 over T1 is equal to V1 over V2 raised to K minus 1. So the entire term here, class, yung naka-raise to K minus 1, not just the initial volume. So be careful of your inputs in your calculator. Next one will have the relationship of the temperature to pressure. So this is P2 over P1 raised to K minus 1 over K. Okay? Next, so you need to remember this, class. If you have some like phrases to remember this, some of my classmates before are reading this in, like, for example, they're reading this as key and they're reading this as kick. So T2 T1 V1 V2 key, parang ganun. And then P2 P1 kick. Anyway, so find a way to remember these equations. Next naman, for the work of a non-flow system, we'll have work non-flow is equal to integral of PdV, or basically this will be equal to P2 V2 minus P1 V1 over 1 minus K. Or we can also write this as using the MRT. So MR delta T, T2 minus T1 all over 1 minus K. Yan. So this is delta PV, right? And then that is equal to MR delta T. That's why you can have two formulas for the work done flow. Next one, for the change in internal energy. For the change in internal energy, that is just the same as our general equation, no changes. Same with the enthalpy. So this is 3, this is 4. Change in enthalpy is MCP delta T. Next, since in an isentropic process, this is a reversible adiabatic process, our heat transfer in an isentropic process is 0. Next, in an steady flow system, the work in a steady flow system is equal to negative change, sorry, this is delta PE plus delta KE plus delta H. Or, pwede na itong mawala, magiging negative delta H lang siya. If it is assumed that your delta PE and delta KE are negligible. Or we can have your work steady flow as K multiplied by the work non-flow. This is if also your delta PE is 0 and delta KE is 0. So since this is an isentropic process, lastly, the change in entropy is 0 since your initial and final entropy are equal. Okay, so help needed from you class is to remember this formula, these equations here. If you have a phrase that is easy to remember, please share it with your classmates. Okay, so let's have a sample problem. Sample problem number, is this 40 already or 39?
40 po.
40. Okay, thank you. From a state of 2070 kPa, 2.8 cubic meters, and 115 degrees Celsius, helium undergoes an isentropic process kPa gauge. Determine a final volume. Letter B, change in enthalpy and change in internal energy. Letter C, we will be going to find the heat transfer. And letter D, the work if the process is non-flow. So, okay, sample problem number 40. From a state of 2070 kilopascals, 2.8 cubic meters, and 115 degrees Celsius, helium undergoes an isentropic process to 2.0 kPa gauge. Determine the final volume and final temperature. Next is the change in enthalpy and change in internal energy. Next, letter C, we are going to find the heat transfer. And then letter D, we're going to find the work non-flow. Okay, so let's analyze the given data. Hala, okay. Given. We have so everything here is initial state. So we have P1 equals 2070 kilopascal. V1 is 2.8 cubic meters. And T1 is 115 degrees Celsius. What is this in Kelvin? Class?
388.15 po.
Okay, thank you. This is 388.15 Kelvin. Next, we are given ng pressure 2 which is 2 kPa gauge. So we will add PATM here. So since this is a P gauge, we'll add the atmospheric pressure, which is 101.325 kPa. So answer here is our final pressure is 103.325. Next, unahin muna natin hanapin yung properties ng helium. So this is helium. Ibibigay ko na lang pala. Aside from air, if not air yung given, I'll give the properties of the gas. But yung K nito, yung K value class ng other gases, I think nandun yun sa inyong notebook and previous notes. So you have to remember the K value of other common gases. But for like CP and CV, that will be given in your exam or in your quiz. Okay? Again, remember yung K values of other common gases, you have to remember them, but the CP and CV values will be given. If not air yung nasa problem. For air, you have to remember the CP and CV, but for the other common gases, you need that will be given. Except for the K value, which you have to remember. Okay, so let's solve this problem. Last problem for today. So first one, we are going to find V2 and K2. So for helium class, what is the value of K from your notes? Do you have the value of K for helium sa notes nyo? Please check your notes. Kasi if wala, we will be adding the K value of helium.
1.667 po.
Okay. So K for helium is 1.667. So we will be using this K value. So to solve for V2, V2 first, we are going to use the formula here. Oh no, I did not write the formula. Okay, let's add the formula for V2 here. In the relationship of volume and pressure, so we are going to add dito na lang sa kabila. V2 over V1 is equal to P1 over P2 raised to 1 over K. Okay? So that's the relationship of volume and pressure. So we are going to use this formula in our problem. So we have P1, P2, we have V1, so V2 can be solved. So for the first one, we are going to use V2 over V1 over P1 over P2 raised to 1 over K. So let's substitute. So this will be V2 is equal to V1, 2.8 cubic meters. Kinaros multiply lang class. And then P1 natin is 2070 kilopascals. And then our final pressure is 103.325 kilopascals raised to 1 over 1.667. So what's our final volume class? Claudine, what's the final volume? Claudine Alvarez. Wala. Dave Simon. Cubic meters. Okay. So 3 decimal places tayo. 16.907 cubic meters. So this is your final volume. So class T2, delta H, delta U, Q, and work non-flow will be your assignment. And i-add natin yung sample problem number 41. Sample problem number 41, an ideal gas having a mass of 2 kilograms at 465 Kelvin and 415 kPa expands in a reversible adiabatic process. To 133 kPa. The ideal gas constant is 0.242 kilojoules per kilogram Kelvin, and K is given to be 1.40. Determine A T2, B delta U, and C work non-flow. Okay, class? So your assignment is sample problem number 40 from T2, delta H and delta U, Q, and work non-flow. For sample problem number 41, you need also to solve this. So requirements are T2, final temperature, change in internal energy, and work non-flow. Okay, any questions, class? Sana ibalik ng F to F. Charot. Ayoko na ng online. Anyway, yun lang, class. Dismiss na tayo. Goodbye. Thank you, everyone. Yes,
Thank
thank
you.
you.